Hi guys, today we're going to talk about solving systems of equations using elimination. Elimination, our goal is to eliminate one of the variables. So if you look at the first system of equations, okay, this is my first system, we want to eliminate one of the variables. And what we're going to do is I like to always add down, okay, because we don't have to worry about signs so much when we're adding. We just need a positive and a negative to cancel something out. So if you notice over here with these equations, the positive y, if I add down, the positive y and the negative y will cancel out. And I get to eliminate one of those variables. So when I add down, I get 0 there, and I'm just going to cancel them out. And then I'm going to add everything else down. So x plus x. And if you want, you can put a 1 in front of the x. So 1x plus 1x, and we get 2x. And on the other side, we add down 3 plus 1 is 4. And now we're just going to solve the equation using equation solving principles. So we're going to divide both sides by 2. And we're going to get x equals 2. So for my solution, remember a solution is a coordinate pair. So for my solution, I already know that the x value is 2, and I'm going to figure out what the y value is. In order to do that, I'm going to take this 2 here. We know x equals 2. I'm going to substitute it into either one of the top equations. I'm just going to put it in the top one. It doesn't matter which. I could put it in the second one, but just plug it back into one of the original equations. So instead of writing, I'm going to plug it into the x plus y equals 3. And so instead of writing x, I'm going to write 2. Oh, sorry. Trying to get to black here. I'm going to write 2. And then everything else stays the same. And so now I'm just going to solve this like I would to solve for y. I'm going to subtract the 2 on both sides. I'm going to get y equals -5. That's the coordinate for the y value. And that's how I would solve a system using elimination. That's one of the really straightforward problems. So this is another straightforward problem. If I'm looking to add these down, when you look, if you look at the x's, if you add them together, you get 4x. So that won't eliminate anything. But if I look at the y's, I have a positive 2y and a negative 2y. So if I add them together, I'm going to get 0. So I'm going to cancel those out. And then I'll add everything else down. So 1x plus 3x, I'm going to get 4x. And on the other side, I add -7. I'm sorry. I'm going to erase this -3 here. And I'm going to just make it a +3, just so we can stick with whole numbers. So, excuse me. We have -7, and we add that with +3. We're going to get -4. And from there, I'm just going to solve this now for x. I'm going to divide both sides by 4. And x equals -1. Again, I know the x value for my coordinate pair or my solution. And I have to figure out the y. So I know what x is. It's -1. I'm going to plug it into either one of these equations up here. It doesn't matter which one. Again, I'm going to plug it into the top one, but you could plug it into the bottom one. It's just a little bit more math you'd have to do. So let's use purple here. So it's x minus 2y equals -7. And I know x equals -1, so I'm going to substitute that right in. So I'm going to write -1 minus 2y equals -7. And then I'm going to solve. So I'm going to add 1 to both sides. And I'm going to get -2y equals -6. Sorry, we're cutting short on the room here. So I'm going to just erase a little bit of what's up here. Just a little bit so I can have some room. So I'm going to write this again. -2y equals -6. And then to solve that, I'm going to divide everything by -2. And I get y equals 3. That's my y value for my solution. And that's my answer. Now, if I wanted to check this, I could plug the -1 in for this x and the 3 in for this y and make sure it's a true statement. That's how you can verify that your work is correct. We're going to do a couple more problems. So let's just look. the next couple of problems, you have to do a little bit more work to be able to cancel out or eliminate one of the variables. Remember, our goal is to get one variable by itself. So you're only working with solving equations with one variable. So let's say we have this one, 3x plus 4y equals negative 6. And then I have 7x plus 4y equals negative 14. Now, if you look when you add down, if you add your x's down, you get 10x. You don't get 0, okay? So that doesn't help us. And if you add your y's down, you would get 8y. That doesn't help us. So I have to multiply one of the equations, or sometimes both of the equations, by another number in order to make it so that when you add down, you're going to get a 0. Now, I noticed that they both have the same number here for the y's. They both have the same coefficient, which is 4. So if I want to get rid of that, I could make one a negative 4. So in order to make one of them a negative 4, I'm going to make this one a negative 4. I'm going to multiply it by negative 1. And when I do that, I have to multiply every item, not just this times this or this times this, but also what's on the other side of the equal sign. I have to multiply them all by negative 1. And when I do that, I'm going to rewrite it over here. I'm going to get negative 7x, negative 4y, and positive 14. And then I'm just going to take this equation here and just rewrite it down here, okay? So I'm just going to rewrite that one, which is 3x plus 4y equals negative 6. So this is the same equation over here. I just copied it down. And now you notice when I look at my y's, if I add down, it's going to cancel out. Sorry. So I'm going to just cancel out the y's. They would become 0. And I'm going to add down negative 7x and positive 3x is negative 4x. And on the other side, I have 14 and negative 6, which is a positive 8. You divide both sides by negative 4. X equals negative 2. So I know the x value in my solution is negative 2. Now I have to find the y value. So now that I know that x is negative 2, I could plug that in here, or I could plug it in here. To be honest, in this one, it doesn't seem to make much difference. I'm going to go with the smaller numbers because it just makes math a little bit easier. So I'm going to plug that in. So I have 3 times x, and instead of writing x, I'm going to write the negative 2, okay? I'm going to plug that negative 2 in there. And then plus 4y equals negative 6. And now I'm just going to do my math, okay? So 3 times negative 2 is negative 6, plus 4y equals negative 6. I'm going to add 6 to both sides. Positive 6 and negative 6 zeros out, so I'm left with 4y on this side of the equal sign. And a positive 6 and negative 6 is going to give me 0. And I divide both sides by 4. And remember that any number that we're dividing 0 by is going to be 0 because 4 goes into 0 times. Right? 0 on the top, the answer is 0. 0 on the bottom would be undefined. Okay, so our y value is 0. And so I'm going to plug that in over here for my y coordinate. And my solution to this system would be negative 2, 0. Now we're going to do one more that's a little bit more difficult, just so you can see the different process and how we have to figure things out. And everybody's not going to do elimination the same way. You might have a different way of doing it. Okay, so there's always more than one way to do elimination. All right, so we have 3x plus y equals 11. We have 6x plus 3y equals 24. Now, again, when I look at my x's and I add them down, you'll notice that they get 9x. So you do not get 0. So that's one we have to look at. And then we have, if we add our y's, we would get 4y. Okay? And so I need to multiply something. All right? Now, I want you to pay attention because to get the x's to 0 out, I could multiply the top equation by negative 2. Because if I multiply the top equation by negative 2, you'd get negative 6x, and you could eliminate your x's. Another thing you could do, if I look at the y's, I could multiply the top equation by negative 3 because I'd get negative 3y, and so negative 3y and positive 3y would zero out. So you get to choose which way you want to do it. Everybody's going to choose a little different way, and that's okay. So I think I'm going to multiply the top one by negative 3. This seems like easy math. And remember, when I multiply every single item, even the one on the other side of the equal sign. So I'm going to get negative 3 times 3x would be negative 9x. Negative 3 times y is negative 3y. And negative 3 times 11 is negative 33. Whoops, not 32. Hold on. Negative 33. Sorry, getting ready for the holidays. Okay. And then we're just going to rewrite the other problem under here. 6x plus 3y equals 24. And now I'm going to add down. So negative 9x and positive 6x is going to be negative 3x. This negative 3y and positive 3y cancel out. And on the other side, we have negative 33 and positive 24. That's going to give me a negative 9. And again, now I'm just going to solve this by dividing each side by negative 3. And we get x equals 3. So I know in my coordinate pair, the x value is 3. Now I have to figure out what the y value is. And in order to do that, I'm going to take this 3 and I'm going to plug it into one of the original equations. I'm going to plug it into the top one. It just seems like the lower numbers, easier math. So I always like to take the easy route out. Never want to work harder than I have to. So I'm going to plug in. So we have 3x plus y equals 11. And I'm going to plug in a 3 here. Let me put it in a different color. So x is 3. So I have 3 times 3 plus y equals 11. And 3 times 3 is 9. So I have 9 plus y equals 11. Subtract 9 to get the y alone. And you're going to get y equals 2. My y value is 2. So the solution to that system would be positive 3, positive 2. And if I plugged it into either one of the two, let's say I plug this x in here, and I plug this y in here, and did the math, it should add up to 24. Okay? So that's how we would solve system of equations through elimination. It's really a great, easy way of doing this. I just want to point out one last thing. Sometimes when you're solving a system of equations, you might end up where you cancel out both the x and the y, and you're just left with numbers. So let's say you're left with something that looks like this, or this, or this. If there's no variables left and you're just left with numbers that equal each other, you should say infinitely many solutions. Okay? Now, sometimes you might be left with the variables. There's no variables left, but the numbers don't match. Okay? When the numbers don't match, that's going to be a no solution. Okay? That means no solution means they're parallel lines. Okay? They would never intersect. Infinite solutions means it's the same line. And that's how you would determine if it's infinite solutions. There'd be no variable left. No solution, there's no variable left either. But infinite solutions, the numbers are equal to each other, and no solution, the numbers are not equal. Okay? That's how we would do solving systems of equations through elimination.